12.1 Sequence and Series. In chapter 12, we're going to look at this 12.1 and then 12.4, the last sections, binomial theorems. So sequence and series, what is a sequence? A sequence is basically a function. Okay? A sequence is a function, but however, that functions, our inputs will be an integers, meaning it should be, I should say, positive integers. So it'll be 1, 2, 3, 4, 5, 6, 7, and then all the way up to starting point that you want. So the number that you substituted in has to be positive, and if you have an and to it, then that will be a finite sequence. That's what we call it. So this first definition is a finite sequence, which is a outcome of a functions when you plug it in just a positive integers. The second definition is basically given to you that is an infinite sequence. So infinite sequence is also the same thing as finite sequence, is the functions and substituting a positive integer. In this case, this positive integers, you can go as far and as large as possible that you want, and it will never end. So it doesn't have an end to it. Now, each output of those output from those functions are called the term of a sequence. So this is basically referring to the first term, and this is referring to the second term, and so on and so forth. So if you have an n, if it is a finite sequence, you will have the last term. If you have infinite sequence, you don't have any last term. So what we want to do in this section is being able to compute, first a few terms. So every sequence has a formula because it is a function. So let's take a look at on the first example. It said that write the first three terms of sequence whose general term, usually they will say the nth term, is given by this formula a sub n is equal to n squared minus 1. So this is like more of like a function notation, but written for a sequence in sequence notation. And this is the formula for the sequence. Okay. So if I want to find the first three terms, that means I'm looking for a sub 1. So therefore, I'm going to be substituting my n with 1, so it'll be 1 squared minus 1, which is going to be 1 minus 1 equal to 0. If I'm looking for the second term of the sequence, that means a sub 2, and I'm going to be substituting this 2 into the formula, so 2 to the second power minus 1, which is equal to 4 minus 1 equal to 3. If it is the third term, it means a sub 3, so 3 to the second power minus 1 equal to 9 minus 1, which is equal to 8. Now we got the first three terms of the sequence, which is 0, 3, 8. That's the first three terms of the sequence. And of course, if you want to continue, this will be endless because as many n value that you want, right, integer, as long as it's integers, it will give you an outcome from this formula. So let's take a look at on the next example. You want to find out the first three terms of the sequence, whose general terms is 3 times n to the second power. So my first term, a sub 1, that will become 3 times 2 to the 1 power, which is 3 times 2, that give me 6. A sub 2, the second term, it will be 3 times 2 to the second power, which is 3 times 4, that is equal to 12. a sub 3, that means 3 times 2 to the third power, that is 3 times 8, which is equal to 24. So now we got the first three terms of the sequence, 6, 12, and 24. So now the next example, the next topic that we're going to get into is what is a series. Series is basically the sum of the terms of the sequence. So the first definition is a infinite series. Okay, an infinite series is basically a series that adds up all the terms of the sequence. Since it is infinite series, you have to talk about associated with infinite sequence. Okay, and the second definition is basically talking about the partial sum. The partial sum. The partial sum is the sum of first n terms of sequence. Okay, so the partial sum is only what you're adding up first a few terms. It will specifically tells you how many terms that you need to add it up. So that's called partial sum. So yeah. Okay, and an infinite series. So I made a mistake right here, right? This one is infinite. An infinite series is the sum of all the terms of a sequence. So the first definition is just basically a series, because a series is sum of an infinite sum of the terms of an infinite sequence, but we're gonna have to define carefully, like based off on it's gonna be a partial sum or infinite series. So partial sum is only first a few terms, okay, and infinite series is all the terms of the sequence. So those are the two different things. Okay, sorry about that. So let's talk about this first example. Find S of 2 for when the sequence is given to you, a of n is equal to -1 to the n power over n plus 1. So S of 2, that's basically talking about the partial sum. And then you are at the 2 representing that you're going to be adding only the first two terms of the sequence. So in this case, first I'm going to have to look for what is the first term of the sequence. That will be equal to -1 to the 1 power over 1 plus 1, which is equal to -1 over 2. And then I'm going to find out the second terms of the sequence, which is a of 2 is -1 over 2 power, and then 2 plus 1, which is going to be a positive 1/3. So now I can find out my partial sum, because partial sum of those two terms, right, as 2 that's representing, that means a sub 1 plus a sub 2, which is equal to, in this case, -1/2 plus 1/3. That is equal to, when you use the calculator or when you do it by hand, this will become -1 over 6. And that will be the partial sum of this given sequence. Then what we're going to do is we're going to look at this partial sum in terms of summation notation. And that notation is a must that you need to get used to with it, because if you're going to go into statistics, a lot of formula is using in summation notation. So summation notation is written by a uppercase of a Greek alphabet sigma. So that is the summations, right? Sigma. And this entire notation is a summation notation. So what we're going to do is we're going to break it down one by one, and then let's talk about this. So the summation notations will always include the formula because the formula will tells you where to plug in the numbers, right? So you have a formula and you're gonna have the index, and the index will tells you the bottom part will tells you where the starting point is, and in this case we call it lower limit of summation. And this on the top of the summation, that is the end, where it's going to be when the series going to be ends, right, where you're going to be stop adding, that is upper limit of summations. So if you say that the index is from 1 to n, you're going to be looking at the end first, the sum of the first n terms of the formula, which is same thing as talking about the series, right? Partial sum. So let's take a look at on this example. Find the sum of I equal to 1 to 6. So we know that we're going to be starting from I equal to 1, and we will end at when it is 6, and I'm giving you the formula right here, 2i. So when I start this process, that basically means I'm going to be adding 2 times when my I is 1, plus 2 times when my I is 2, plus 2 times when my I is 3. So that's basically you're looking at each term, plus 2 times when my I is 4, and then plus 2 times when I is 5, and then plus 2 times when I is 6. So you're looking at this as, the first term, a sub 1, this will be the second term, a sub 2, and then so on and so forth, all the way up to the sixth term. So if I add all of this up, 2 plus 4 plus 6 plus 8 plus 10 plus 12, this all together, that give me the partial sum, which is in this case is what the partial sum of this 2i, the sequence, right? In general term sequence 2i. So it will be 10, 20, 30, 42 is my final answer. So we will do this kind of example more later on after we talk about the factorial notations. Factorial is another notation that you need to know so that you can compute the counting rules of some counting rule of the probability in statistics. So what is a factorial notation talking about? Factorial notation is defined to be this way. If n is a positive integer, the n factorial, okay, is defined to be with the notation with n exclamation mark. That basically means that you're going to be start multiplying from n, and then n minus 1, which is 1 less, and then n minus 2, which is 2 less value, all the way to 3, 2, 1. So you are looking for n factorial is basically the product of n to all the way to 1, which is the lower. And also with one exception definition right here, 0 factorial is equal to 1, not 0. So with these definitions, now we're going to try the problems. So in this case, I want to find the first 3 terms of the sequence where the sequence has a formula of factorial symbol involved. Right? So let's talk about the first 3 terms. So the first term will be equal to what? 2 to the first power over 1 factorial. That means 2 to the first power is 2, 1 factorial is 1, because the 1 is the smallest number now, is equal to what? 2. A sub 2, that is 2 to the second power over 2 factorial. That is basically 2 to the second power is 4. 2 factorial, that means 2 times 1. This gives me, according to the definition, so this gives me 4 divided by 2 is 2. Now a sub 3, that is 2 to the third power over 3 factorial, according to the formula. So this gives me 2 to the third power, we know that is 8. What is 3 factorial? according to the definition, 3 factorial is a product of numbers starting from 3 and all the way down to 1. So it'll be 3 times 2 times 1. That is equal to, when I reduce this will be 4 over 3, because 2 goes into 2 one time, 2 goes into 8 4 times. I reduced it. So now we got the first 3 terms of the sequence, which is 2, 2, and 4 over 3 for this formula. Let's take a look at on the last example right here, right? Asking you to find the sum of a given formula, which is a sequence. So we know that the starting point is from 0, and then the end point is 3. So when I talk about the sum of k equal to 0 to 3 of 1 over k factorial, that is basically talking about 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, because k is going to go from 0 to 3. Now let's simplify this part. According to the definition, 0 factorial is equal to 1 plus 1 over 1 factorial is basically 1. That's it. Plus 1 over 2 factorial, that means 2 times 1. And plus 3 factorial, that's mean basically 3 times 2 times 1. So now, which we get 1 plus 1 plus half plus 1/6. So everything's going to be LCD 6. So I can say that 6 plus 3 plus 1 all over 6, right? That will become 16 over 6, which is 8 over 3 is my final answer. So make sure you practice on the summation notations and then factorial notations. And this will end this section.